Hello and welcome to XQ. Today I'm going to do a full demonstration of XQ's Vault product. This is our data encryption at rest product and it works cross-platform on Windows, Mac, and Linux. This allows you to encrypt data directly on your device itself before it's stored in any target destination. This target destination can be any local folder, network access storage device, your cloud storage solution providers such as OneDrive, Drive, and Dropbox, as well as your object-oriented storage platforms such as S3 and Azure Blob. In this demonstration today, I'll utilize OneDrive and Azure Blob. We try to keep things as simple as possible for the end user, so all they have to do from their end is simply connect the target destination. Here I'll connect my OneDrive solution, and what you'll notice here is it'll spin up a virtual file share that looks identical to your local file system. So in Windows, this will spin up essentially a Windows Explorer. Any data ingested within this location will be encrypted directly on your device itself and then stored within its target destination, and vice versa when you're accessing data within this location. So as an example here, I'll upload my instructions.txt file. My device will actually encrypt that data directly on my device itself and then store it within OneDrive. Accessing the data, you can utilize all the same local applications you typically would, and just simply interact with data as you normally do. So for example here, if I wanted to open this instructions.txt here, I can just simply double click and the application itself will handle the full authorization, request for key, and decryption events directly on my device itself. All of this is logged within our management portal. So here I'll open up our management portal, navigate to the communication section, drill down into a specific file itself, and then you'll notice all of the full who, what, where, when for each individual access attempt. So you'll notice that I access this file at this time at this location. This platform is actually built with integrations. So this can be integrated directly within your Microsoft AD. So you can segregate out specific access to data based on specific groups. So for example, my user that I'm utilizing right now is part of the HR group. So any users within the IT team won't actually be able to access any of the data that the HR group has access to unless provided access. This helps segregate data access from actual access to information within the data based on specific groups. So for example, if you set up a CMMC team to deal with your CMMC data, your IT team that typically has access to all data within your organization won't actually be able to access any of the data within the files. So here I'll show you an example of that where I'm going to log out and then switch users to my IT team user, and I'll connect the same target directory. Now I'll authenticate with my IT team user. This user has access to all data within the organization as they typically do. I'll connect that target directory, the same one I was connecting with the HR group user, and attempt to access data within this platform like I did with the HR group user. The moment I attempt to access, for example, this instructions.txt file that I previously created, it'll throw me an error that this file cannot be opened. And this is due to this user's inability to actually authenticate and request access to the specific data item. Additionally to this, I'll switch back to my other user and I'll set up some policies to geo-restrict access to specific regions. This is especially useful if you're dealing with certain rules such as GDPR or any other of these geo-restriction policies that are in place. So here I'll navigate back to the portal, go into my policy manager, enable my policy to geo-restrict data access from Canada and United States, which is where I'm located, and then I'll attempt to connect that same target directory with the HR team user as I did before. This should immediately throw me an error that access from my location has been blocked, and it'll actually boot me out back to the login screen. So this policy has been enforced. I'm going to go ahead and turn this policy off and show you what you can do for remediation. So here I'm going to authenticate again. Once authenticated, I'll actually go back into my portal and actually revoke access to that specific file I created before. So here I'm going to drill down into the communications log, go into instructions.txt, and revoke all. Once this has been done, the actual decryption key associated with this file has been suspended or completely destroyed. So now when I actually attempt to connect that target directory and access that file again, my instructions.txt file, it'll throw me an error that this file cannot be opened. this is my device's inability to actually request and access that decryption key anymore and decrypt any of the data locally on my device itself. Lastly, I just want to show you Vault's capabilities to connect to object-oriented storage platforms such as Azure Blob and S3. Here I'll do an example with my Azure Blob location that I have set up on the left-hand side here. So I'm going to connect my Azure Blob, and this will spin up a virtual file system similar to what you've seen with OneDrive. Any data ingested within this platform, again, such as my instructions.txt file, will be encrypted directly on my device itself before it's stored within the Azure Blob location. So you'll notice that both of these files are actually .xqf extensions, just helping you identify that they are encrypted. One of the questions we get pretty often is why would I utilize this over top of existing encryption that these platforms provide? So utilizing XQ's Vault on top of object-oriented storage, you can separate out the encryption from the actual data storage. So for example, if your IT administrator is compromised within Azure or AWS, the hacker won't actually be able to exfiltrate any of the data out from those platforms without you having to go through the immense amount of overhead of uniquely decrypting each individual file within those platforms.